It is often assumed that a bullet's path of flight is in a straight line. Where you aim is where the bullet should hit. If only it were that simple. The ballistics of a bullet, once the firing pin strikes the primer, consists of three components: internal, external, and terminal ballistics. Understanding how guns are manufactured to take on these forces will provide shooters with insight to the bullet's trajectory. Veteran Air Force sniper and long-range expert George Reines helps us demonstrate. As soon as the bullet leaves the barrel, gravity, drag, and wind force start acting on the projectile. Most sights on a gun are above the bore of the gun, and the sight must be aligned at a certain point known as zero. To achieve this, the barrel of the gun must be pointed upward so that the path of the bullet meets the crosshairs at a given distance. The bullet will then rise above the line of sight, creating the shape of a half circle as it meets the same impact point at a farther distance. This is known as bullet trajectory. After reaching the second zeroing point, gravity pulls the bullet from the line of sight. The rate at which a bullet drops over distance is caused by gravity and is a function of bullet speed. Given a specific distance, the higher the bullet speed, the less time it is subjected to the effect of gravity and the less it drops. However, bullet speed is not a constant and can start to decrease as soon as the bullet leaves the muzzle due to drag. Gravity isn't the only thing affecting a bullet in flight. Drag, air resistance, and wind deflection are all factors in slowing down or pushing a bullet away from its target. Drag is determined by bullet speed, ballistic coefficient, and air density. It also increases when bullet speed relative to air increases. When a bullet's ballistic coefficient is high, it is more efficient against drag. Finally, a factor known as wind deflection can play a critical factor on bullet trajectory. Wind will affect the vertical or horizontal component of the trajectory by causing deviation of the bullet's flight path. When the wind blows against a mountain, hill, or tall building, it generates a vertical component. Vertical wind can blow up or down, and the bullet will be deflected in that same direction. Because of these factors, long-range shooting can be extremely difficult to be precise. Understanding your environment and taking gravity, drag, and wind into account, you can be a successful long-range shooter. For Firearm Science, I'm Jessie Duff. See you next time.